In this video, I'm going to show you a quantitative risk assessment that was used for a trade issue between the United States and China. The story begins here in the United States. In the United States, we grow a lot of wheat in the middle of the country, and much of the wheat that's grown here moves down the Mississippi River and out through the port of New Orleans to other points. We also grow winter wheat up in the Pacific Northwest part of the United States, and this wheat moves through ports in the Pacific Northwest to destinations. The United States enjoyed a rich and profitable wheat trade with China for many years. And in 1973, China embargoed U.S. wheat from the Pacific Northwest. They enacted a zero tolerance on TCK spores. This is a fungus I'll show you in just a second. U.S. wheat farmers were more convinced that the real reason for this was to protect Chinese wheat farmers from competition with U.S. wheat. So let's have a look at these TCK spores. TCK stands for Talacia controversa, and it is simply a fungus that affects wheat. What it does is what you see right here to the wheat. It reduces wheat yields, and it does it in a way that does no harm to humans, no harm to animals. The only harm it does is it reduces wheat yields. In the 1990s, China wanted to join the World Trade Organization, and this opened up an opportunity for the United States to support China's application to the World Trade Organization, but the U.S. wanted something in return. And one of the things that it wanted was access to Chinese wheat markets again. So the World Trade Organization adopted something called the Sanitary and Phytosanitary Agreement, the SPS agreement. The short version of this goes something like this. Any country that belongs to the World Trade Organization agrees to accept the products of other members of the World Trade Organization. Now, they can refuse a product if they believe that product would harm human, animal, or plant life and health in their own country. But to avoid political or economic sanctions on trade, the SPS agreement said that the justification for this must be scientific and that the science must be shown in a risk assessment. So this SPS agreement was really critical in causing the spread of risk assessment around the world. It basically said that if you're going to trade, you've got to know how to do risk assessment. So the United States, knowing that China wanted to join the World Trade Organization, decided that we would do a risk assessment on TCK and its effect on China. Now, typically what happens is when a country wants to send a product to another country, let's say if Côte d'Ivoire in Africa wanted to send timbers to the United States would do a risk assessment of that timber. They would identify all the pests, all the bugs and worms and everything else associated with that particular tree to assure that they were either already present in the United States or that they could not become established in the United States. So establishment of these pests is the critical issue in a lot of trade risk assessments. So let's take a look at the risk assessment that the U.S. did, because typically what would happen is the United States would do that risk assessment on those timbers from Côte d'Ivoire, and then it would either allow the timbers in or tell Côte d'Ivoire how they would have to treat those timbers before they would be accepted, or we would embargo them and say they're not allowed in at all. So typically, the importing country does the risk assessment. In this case, in the late 90s, the United States says China wants to join the World Trade Organization. That means they're going to have to make trade decisions based on risk assessment. The United States Department of Agriculture knew that China wasn't doing risk assessment and that we would have an advantage because we know how to do it. So even though we are the exporting country, the United States undertook the risk assessment that you're going to look at now. I worked with a team of about 26 scientists on this, And it was very high priority because it was going to be the matter of discussion between the President of the United States and the Prime Minister of China. You'll notice here that this says this is not the actual data, and that's true. I am allowed to use the model, but I can't use the actual data because of the controversial nature of this risk assessment. So consider these data realistic, but not the actual data that was used for China. Now I'm going to show you this model is color-coded. So we see some white here, and then some gray, some darker gray, some yellow, and a bit of red. So let me tell the story of this risk assessment by colors. In the white part of this model, what we do is estimate the number of TCK spores that would be exported to China. Here you see 10 to the 13 spores would leave the United States in the wheat that was bound for China. In the gray, what we do is we tell the story of what happens to those wheat spores once they get to China. So skipping the details for the moment and jumping down to row 29 here, the number of spores that could be dispersed to wheat fields, of the 10 to the 13 spores, 10 to the 12 of them could be dispersed to wheat fields. The dark gray estimates the percentage of China's wheat land that would be conducive to establishment. Here you see it is less than 1% of all China's wheat land would have the life requisites for TCK to become established. And that would include things like 6 months of snow cover and certain soil requirements, rainfall requirements, and that sort of thing. In the yellow area, we estimate the number of spores of the 10 to the 12, how many of them arrive at land that's conducive to establishment. We estimate the number of spores per conducive hectare, and then we compare that to this critical number here. This is the number of spores per hectare that are required for TCK to become established. So you need 86 million spores on a hectare of land in order for the TCK to become established there. We compare this number, 86 million that's required, to the 51,000 that is present, and we see that this falls short by almost 86 million. So if this number here is smaller than this number here, then we have a 0, which means no establishment. If this number here is bigger than this number here, then there would be a 1 that would appear here, which would mean we would have establishment. So let's go back and look at just a little bit of detail now. The annual tons of wheat sent to China from all U.S. origins, this is a number that we don't know. This is in the pile of things that we don't know because it varies from year to year. So this is natural variability. You'll notice here that we have a normal distribution with a mean of about 3 million tons and a standard deviation of about 2 million tons. It's truncated at 0 because negative amounts of wheat are not possible. So what happens is when we hit the F9 key, which I'll do in a second, the computer randomly selects a number from this number line, but it follows this rule. It picks numbers in the fat part most often, numbers in the skinny part least often. So I'm going to turn on the Monte Carlo process, and we could have 4 million, 4.2, 2.7, 2.3. These are different amounts of wheat that could move from the United States to China. The next thing we want to know is where does the wheat come from? And this was a matter of knowledge uncertainty. Back in the 1990s, even though we had good data on the amount of wheat going to China, no one kept track of what port it moved through. And so we had our experts estimate it was no less than 30% coming from the Pacific Northwest, no more than 70% of the China-bound wheat coming from the Pacific Northwest. Do we know anything else? Their most likely estimate was 50%, and that gave rise to this triangular distribution. Don't worry, I'm not going to do every cell, but I want to get you off to a start here. And so we take a look at the wheat. Uh, this is a calculation, this number times this number. Now what we want is the number of spores in a ton of wheat. And here you see we have 36,000 spores in a ton of wheat from the Pacific Northwest, 520 spores in a ton of wheat going through the Gulf of Mexico. If we take a look at this distribution, this turns out to be a cumulative distribution because we had fantastic data for this. There were thousands and thousands of data points. So there is no knowledge uncertainty here at all, but there is plenty of natural variability. So doing the arithmetic, the number of tons times the spores per ton, we calculate a number of spores that would be exported to China. In this dark gray, we now see that most of the grain is going to be used for milling. In this case, about 96%. That means 4% of the grain falls off the back of the truck. And that would be a euphemism used here in the United States to mean we can't account for it. It was stolen, it was misplaced, but we can't account for it. And as you trace down through here, you would find that spores could be spread while the grain was being handled or while the grain was being milled. We also have down here spores that would be fed to livestock. So here in row 18, we have some spores that would be fed to livestock. The livestock would go out in the fields and do what they do naturally. And we looked at every way we could imagine that spores could get from the dock to wheatland. And if you followed this story all the way down, you would see 10 to 11 spores make their way to wheatland. By the way, as we go, you'll notice in cell C here, this is the arithmetic, this is the formula that you would find in the corresponding B cell. So there's nothing complicated about this. It's basic arithmetic, multiplication, addition, division. Down here, one of the things that took a great deal of time was to estimate the number of hectares of land that China had devoted to wheat. This was done using satellite imagery to estimate the number of hectares. And then satellite images were used to estimate how many of those hectares would be conducive to establishment of TCK. So these numbers in here are provided based on data that was obtained from satellite imagery. This is uncertain also, you'll notice. We don't know what those values are. In fact, everything in this model is uncertain. It's either subject to natural variability or there are facts that we just do not possess. So using the basic arithmetic here, taking this number of spores and spreading them over this number of hectares, we get this number of spores per hectare. Here we have, let me see, almost 1 million spores. That's still 85 million spores short. So if I place my cursor here, excuse me, and if I use F9, you'll see the numbers changing, but that zero is not going to change. We did 100,000 iterations. Each iteration is like a year of trade. So here's 1 year of trade, no establishment. Here's another year of trade, there was no establishment. And we did simulations of 100,000 iterations each. So that would be 100,000 years of trade we were simulating. And not once did we have establishment. So we could argue that the probability of establishment is certainly less than 10 to the minus 5. We then stepped back and said there's a lot of uncertainty here. So let's see if we could break this model. So we looked at bioaccumulation of the spores in the ground. We looked at all sorts of alternative scenarios that would increase the number of spores. And what we came up with was basically no realistic chance that TCK could become established. When we wrote up this report, we described those things we didn't know. For example, the probability that spores will survive in the digestive tract of a pig. That is just knowledge uncertainty. There may be a true percentage of spores, but we didn't know that. So we just guessed. It was between 30 and 70%. The horizontal nature of this distribution says every number in here is as likely as every other. That's kind of maximum ignorance or maximum uncertainty. We told the Chinese that we didn't know this, and we asked them if they had data to please share it with us because we would be happy to use better data in place of this. So there was no attempt to make us sound more certain than we were. The risk assessment was sent to China. The Chinese reviewed it. We made 4 trips to China explaining and working with them to understand this. And then finally what happened was the President of the United States met with the Prime Minister of China. And they basically said, well, let's read right here. The embargo lasted until April 1999, when a breakthrough agreement was signed with the United States. The key to the negotiation was the TCK risk assessment that you just looked at. And the heart of the report was a research-driven, quantitative, probabilistic risk assessment model showing a negligible risk of the fungus's spread to Chinese wheat, partly because of China's seasonal climate. TCK spore levels in U.S. wheat exports, and spore levels needed to induce disease. By easing its zero-tolerance policy to 30,000 TCK spores per 50 grams of grain, the United States and China agreed and opened the door to $150 million worth of U.S. wheat exports. So this was an important part of the deal. The 2 presidents shook hands, and they decided that the U.S. would support China's application to the World Trade Organization. I will add one postscript to this story. There was a lot of scrutiny of all these numbers that are changing. Notice the one number that does not change is this 86 million. When we began this risk assessment, we made a pile of things that we know. We made a pile of things that we didn't know. In the pile of things we didn't know was this number here. How many spores are required for TCK to become established? Without that number, there was no way to do risk assessment. So the effort at completing the risk assessment was shut down for 2 years while we did research at 2 universities to try to estimate this number. That research yielded data, and 86 million was used. It's a constant, and no one ever challenged it. And I always grin at that because I'm thinking this is probably the most critical value of all. But because it's presented as a constant, no one ever questioned it. And it might be the least certain of all these values. So this is an example of a risk assessment that was used to resolve a trade issue at the highest levels of government.